Hello everyone, my name is Onur and I'm a cybersecurity semester 4 student at the Fontes Hogescholen. In this video I'll be covering my prowess with cross-site request forgeries as one of my themes of learning goals. In order to set this up, I've set up a website called DVBH, which I've also shown in my previous videos. With this website you can pretty much use any common web technique in order to see whether or not your web technique works or not. For example, SQL injections. Pen testers usually use this website in order to test the skills or improve on certain things that they haven't really touched on previously yet. And in this example, for this video, I'll be using cross-site request forgeries. But it's also possible, for example, to use SQL injections and cross-site scripting. In order to set this video up, I'll be using a combination of cross-site scripting and cross-site request forgery, because the cross-site request forgery in its own is pretty simple. As you can see in this image right here, a perpetrator sends a victim an URL which is meant to look like something innocent. For example, let's say I send you an email with a link in it to my Facebook page, and maybe you want to click on it because I'm advertising that there's some free handouts for software or maybe clothing. So basically I'm advertising free clothing or free software on my Facebook page, and I want you to click my link. This method usually involves some kind of social engineering to convince the user to click your link, and it usually tries to raise your sense of urgency in order to make you forget to check all the details. Because if you open a link which is innocent seeming, you might get taken advantage of. And I will show how this works using the cross-site scripting. The security level currently is low. As you can see, there's a message box. In this previous video I've also shown you how to manipulate this message box, but what I'm just going to do now is increase the max length of this message box. And then there's like a innocent seeming message: follow my Facebook page, free goodies. So what the victim will end up seeing is something simple like a Facebook page with an URL which is meant to look like one. But if we look at the bottom left, we can see that this obviously isn't the case. It's a malicious website which is hidden and something innocent seeming. And if you open the link, we will open the actual form which changed the password, and I will explain to you how this form changed your password. We can see right away in the URL bar of this website that this website uses some kind of GET request or some kind of API. Either way, the information is exposed to us and we can see what the information is. A better hack wouldn't show you this page at all, but we'll come back to that later. This form uses a GET in order to see what the changed information was from the form, and the form indeed uses these variables to get these, and then it just changes your password in the database, which is pretty simple. But using this, the user would immediately know whether or not this password has changed, and he would try to change it afterwards, so you wouldn't be able to log into his account, which is pretty obvious, I thought. So if you go back to the cross-site scripting page, we're going to do something much more malicious. But before we can do that, we need to increase the length of this form. Right? And as you can see on my Visual Studio Code, there is an image with a width of height of 1. And it's designed so that the user wouldn't really notice any image being here. What this does is, once the page is loaded, the cross-site scripting page, this malicious bit of information is still on this page, and what it does is it tries to get an image with this URL, and the result of that will be that your page, the page that you've opened, opens that page within it due to the image tag trying to source the actual form, which means that the code is submitted as well. Like, you might as well put an iframe in this and you'd have the same result most likely. And I will demonstrate to you this effectiveness. So I believe the password used to be 1234, which is a 3-character password. And if we use a 4-character password, which yeah right now, it'll work. So the image source worked. Let's say we raise the security level of the DVH app, and we go back to the XSS. Let's change the password first to a 3-character password, 123, and then we visit this page with the malicious code on it. We log out, we log back in with 123. That doesn't work. What a surprise! But if we log in with yeah, it will work. And why is this the case? Well, it's pretty simple. The medium security level of this website on the cross-site request forgery form, it doesn't check for the token, but what it does do in terms of difference of the low level, it checks whether or not the request came from the same origin as the website itself. So I think it pretty much just basically strips out the entire path and see if it still compares to where the request came from, which means that, let's say I send you this link via email, and you open the link via the email, it would see that the origin of the request came from the email and not from the page, like the own web space itself. And I assume it doesn't work in that context, but in the context of the same page being used, it would work, because this cross-site scripting page is still the same page as the CSRF page, which is pretty logical. Now if we look at the high CSRF source, it becomes a much more difficult thing to deal with. It checks for a token, and I can demonstrate to you how this would look like from the front end. So if we inspect this form, we would see a new input type hidden, which is meant to disguise this from the user with a randomized value. And we can also assume that the backend also has this value. What it does is, like, let's say there is a certain secret that the change button has, and once I press on the change button, it checks if the secret matches with the secret the backend has also generated. Like the numbers generated from the backend pass to the front end in a sort of secret which is hidden and which is randomized. So that means this sort of thing won't work. You need to bypass the user token, or also generate your own user token, and it needs to match up with the randomized user token on the website. And I believe it is possible from what I've researched. A lot of people use the Burp Suite in order to test this, but well, if I get really into the nitty-gritty about this, I need to make another video. So the best way to prevent people using this simple method of changing other people's password or whatever is by doing a check on the token, randomized portion of the form, which is a long numeric value, and check if that numeric value still matches with where the request originated from. And that way you will know whether or not the request was sent from someone actually visiting the page, filling something in and then pressing a change, or some joker using an image tag on a web page, on a forum, or whatever. Anyway, my name is Owner, and thank you for listening. Until next time.